Hello everyone, my name is Nathan Tran from 4th period Mr. Anderson's science class, and I'm going to be teaching you about parts of an atom, valence electrons, the mass of the parts of the atoms, the octet rule, how to draw Lewis dot structures, and how to draw Bohr models. So, and as Philip DeFranco says, let's just jump into it. Okay, so the first thing I'm going to talk to you about are the parts of an atom. So, you see this, oh wait, okay, so you see this lumpy thing right here? This is a nucleus. So, and this thing is made out of two major things. Protons, which will be this, and it'll be labeled with a P, and neutrons, which will be labeled with an N. So depending on the element, there are different amounts of protons and neutrons. The amount of protons determines which element it is. For example, since hydrogen is number 1 on the periodic table, it has 1 proton. Really cool. And yeah, neutrons have a totally different equation that I think Sanvi will teach you about, so I might teach it anyways. Okay, so this is the middle of the atom, the nucleus, which is actually mostly just empty space, which is pretty cool. And around the nucleus, there's like a cloud, which is called the electron cloud. And in this cloud, there are electrons. So they look like this, I guess. They could look like that. They don't actually travel in a circle like this, though. So they actually like whiz around everywhere, like that. Oh, maybe I shouldn't have done that. Okay, so yeah, electrons are cool. Okay, yeah. And these things, they're pretty fast. They can actually move between atoms, which like does cool stuff, like balance them. And yeah, they have a atomic mass of basically 0, but it's actually 1/1836. So yeah, and they have a negative charge. And protons, they're the opposite. They are positively charged, and they have a mass of 1 AMU. And neutrons, they also have a mass of 1 AMU, but they are neutrally charged, so like they're nothing. It's kind of boring, but okay. So valence electrons, they're the electrons on the outermost ring. So let's say this was helium, and helium is a noble gas, which means that it's pretty stable, and its valence electron ring is full. And helium, since it's at the top row, it only has 1 ring of electrons, so that means this one is full. So the order of the valence electrons goes 2, then 8 for the second ring, then 8 again, then like 18, I think. I don't really remember because it's insignificant and we don't need to know about that. So this one has a full valence shell, which means that it's very, very stable and it's a noble gas. But if we had like sodium, so sodium, no, actually no, let's do lithium. Lithium is number 3. So you see it has 2 electrons, but uh-oh, there's another ring, and this is the valence ring for lithium. This ring right there. And boom, it has a lithium, or it has an extra electron, which it really does not like, so that's why it's like crazy unstable. Like, he's gonna go freaking sicko mode on everyone. Like, yeah, so that's why they, like, okay, never mind. But yeah, so this is unstable, and you see the second ring has to have 8 valence electrons to fill up. So that means this thing is super unstable. And yeah, the second ring actually has a max of 8. So 1, 2, 3, 4, 5, 6, 7, 8. If it has 8, this is actually neon, which is number 10. And neon is also a noble gas like helium. So that means neon is super stable, along with krypton and other cool noble gases. And that's why they're called noble, because they're stable and they're very cool. Okay, the next thing I'm going to talk about is the octet rule. So remember what I told you about how noble gases basically are super stable because they filled up their valence shell full of electrons. Well, so for example, we can draw CO2, which is carbon dioxide, and carbon is number 6, and oxygen is 8. So they have Lewis dot structures that look like this. So 2, so that means carbon has 4. should have 6 with their 2 oxygens. So it should be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. As you know, CO2 is a very stable substance. So how do we combine these by making it stable? Well, the octet rule is here. So there would be like a carbon in the middle, and there would be 1, 2, 4. Wait, no, carbon is number 6. Oops. Okay, so there are 2. So 2 minus 6, that's the inside. So these are the valence electrons on it, because the inside ring is already stable. Okay, and then oxygen, they have 6 each. So there's 1 oxygen here and 1 oxygen here. And this one can also have 1, 2, but then the rest go on the outside.
I drew too many here, but I get rid of them later.
Now, if you look at it, you see that now every atom has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now they're all stable in a happy compound, which is like a noble gas, and it's very stable, but it's not a noble gas. And that's real cool. Okay, the next thing I'm going to show you how to draw is the Bohr model, which shows electrons and stuff. So let's have an element here. Let's make it fluorine, which is number 9. So fluorine, it's a halogen, so that means it's very unstable in group 7. So it has 1 full electron ring, and it has in its valence electron ring 7. 7, and it's very stable, and it wants an electron to get stable, right? So this is actually the Bohr model, where you put the electrons like this, and you can show the valence electron. You can see that, and then you can write it has 9 protons, and it actually has a mass of like 19, so it has 10 neutrons. Yeah, this is a Bohr model, and you can see how many valence electrons there are and how many full shells there are. Wow. And next we're going to talk about the Lewis dot structure, which is just this. So you have the chemical symbol, and you put how many valence electrons are on the outside, which is 7. 7. And then boom. There are 7. This is a Lewis dot structure, which shows the 7 valence electrons that fluorine has.